We will be using exponents during our next section in Algebra 1, and before we begin, we will do a review of some exponent rules that you should have learned in middle school. We'll start with a reminder about exponential form. When you see 5 to the 4th power, what that means is to take 5 and multiply it together 4 times. The number being multiplied, so in this case the 5, is referred to as the base, and the number that tells you how many times to multiply the base, so the little number, in this case the 4, is referred to as the exponent. So you have a base raised to an exponent. So here are a couple examples of exponential form. If you have 8 times a times a times a times a, we could write this shorthand as 8 times a to the 4th. And we would say that because a is being multiplied by itself 4 times. So in this case, the a would be the base, the 4 would be the exponent, and that 8 out in front, you could think of that like another base, but typically what we would call it is simply a coefficient. So it's the coefficient on a to the 4th. Notice that it's not part of the base of a because it's not being raised to the 4th power. If it was being raised to the 4th power, it would have to be in parentheses to show that you wanted 8a times 8a times 8a, so it's not to the 4th. In the second example, we have x times x times x times y times y. So in this case, you have x multiplied by itself 3 times y multiplied by itself 2 times. So it's okay, and something that happens a lot is to have 2 different bases. So x and y are both bases, and each base has its own exponent. The rest of this video will be concerned with doing operations like addition and multiplication on terms that have exponents in them. So we'll start with adding and subtracting. So here's a term with exponents, we're adding it to another one, we're adding it to another one, we're subtracting, adding again, adding a negative 4. So when you have this situation where you're adding and subtracting all of the terms, the rule is that you want to add the coefficients of terms that have exactly the same bases and exponents. And when you do that, you're going to keep the bases and exponents the same. And I should have said, I think this would be more clear, in the answer. So you're going to keep the bases and exponents the same in the answer. So here's what I can add together in number 3. Negative 3x squared and x squared can get added together because they have exactly the same base of x and base of x, and then the x's have squareds on them. And so I'm going to add together the coefficients. So x squared is like a 1x. So 1 and negative 3 gives you negative 2. So you'd have negative 2x squared. I can also add together 5x and negative 2x because they have an x to the 1 power. So this is like terms. So 5x minus 2x makes 3x. And then negative 4 doesn't have any other just numbers, so I can just say minus 4. So my final answer here is negative 2x squared plus 3x minus 4. In number 4, I've got a couple of bases in each problem. In each term. In my first term, I have an m squared. And so I look over here and see that there's an m squared here as well. So I can add together my 4 and my negative 1 and get 3m squared. Next, I see that I have 5mn squared, and over here I have an mn squared. So I can add together my 5 and my 3, and I can say plus 8mn squared. So with adding and subtracting, you can add together basically any like term, and all you're doing is changing the coefficients. You're keeping the variables and the exponents exactly the same. Our next rule has to do with multiplying terms with exponents. Your rule here is to multiply the coefficients and then add the exponents on like bases. So here's what that looks like in practice. If we're doing this multiplication problem, we're going to multiply the 4 times 5 because those are the coefficients. So those are the numbers, basically, that we're using. So that's going to be a 20. Then we have to add the exponents on like bases. So here's an x, and here's an x. So we're going to add these exponents. So we're going to say x, and then we're going to add together 2 plus 3 to get 5. So our answer here is 20x to the 5th. When I do number 6, I'm going to take the negative 4 and multiply it by 7, which gives you negative 28. And it makes sense that we're doing this because it's a multiplication problem. And then we're going to look for like bases. So I have x and x. So this has a 2 and this has a 1. So I'm going to add 2 and 1 together to get 3. So we're adding 2 plus 1. And then for the y's, those are like bases. So we're going to keep those separate and add those. So we're going to take 6 and we're going to add it to 4. So we're going to have y to the 10th. So our final answer here is negative 28 x cubed y to the 10th. Last rule is about raising terms with exponents to a power. So this is saying here's x squared and I'm going to raise that whole thing to another power to the 5th. So the rule here is to raise the coefficient to the power but multiply the exponents. So number 7 doesn't have a number in front of the x, so we don't have to worry about the coefficient. But what we're going to do is we're going to multiply 2 times 5. So in the last problems, when we were doing the multiplication problems, we were adding the exponents. Now we've changed and we're multiplying. So this would be x to the 10th. In number 8, what we're going to do is raise the coefficient to the power. So that means do 2 to the 3rd. But then we're multiplying the exponents. So that means we're doing x to the 2 times 3. So 2 to the 3rd is 8. X to the 2 times 3 is x to the 6th. And that would be our final answer there. Here what we did was just x to the 2 times 5 because we only had the exponents to multiply. In number 9, what we'll do is we'll take negative 3 and raise it to the 2nd because we're raising the coefficients to the power. Then we'll do p to the 3 times 2 and q to the 4 times 2. So negative 3 squared gives you positive 9. P to the 3 times 2 is p to the 6th. Q to the 4 times 2 is q to the 8th. Next we'll go to number 10, which has a fraction in it, but still we're going to do everything the same. We're going to take negative 4 and we're going to raise it to the 3rd power. We're going to have m and we're going to multiply 4 times 3. And on the bottom, we're going to leave all that on the bottom, but we're going to do n to the 7 times 3. So we need to do a little bit of scratch work for negative 4 to the 3rd. If you do negative 4 times negative 4, that gives you positive 16. But then if you multiply that by negative 4, that gives you negative 64. So we have a negative answer because we did a negative times another negative. So to finish with this problem, we'll say that negative 4 cubed is negative 64. M to the 4th cubed is m to the 12th. And we need to put that over n to the 21st since that was our answer. So we can use this rule with fractions inside or with not. It doesn't matter. You just need to take the numbers and raise them to the power, take the exponents, and multiply them. We'll do one last problem where we put all of this together. In this problem, we have to take one thing and square it, take another thing and raise it to the 4th, and then they're multiplied together. So we need to think of order of operations, exponents first. So if I do my first parentheses to the 2nd power, I'm going to take 1/2 and square it, because when you raise everything to a power, you take the numbers and you do them to that power. So if you think about it, 1/2 times 1/2 equals 1/4. So in that first parentheses, and I'm going to keep it that way, I'm going to write 1/4. And then I have x cubed to the 2nd, so I multiply my exponents and get x to the 6th. Y, this is like a 1, so 1 times 2 is 2, so we have y squared. In the second parentheses, I have 2 to the 4th, so 2 times itself 4 times is 16. And then y to the 1 raised to the 4th is simply y to the 4th. So I did my first step. I used that rule for raising something to a power to do that first part. Now it's time to finish up. An order of operations says now that I am done raising the parentheses to the exponents, I need to multiply. So I need to multiply my two answer parentheses together. So that means I need to go back to my other rule, where I multiply the numbers together, or the coefficients. So I'm going to multiply 1/4 times 16, and I'm going to add the exponents on like bases. So there's no other x's in this parentheses, but there are y's. So when I see the y's, I'm going to have to add my exponents. So when I do my answers, I'm first going to do a little bit of scratch work on the side and think about what 1/4 times 16 is. So 1/4 times 16 is 16 over 4, so that's 4. So when I multiply the coefficients, I get 4. There are no other x's, so I can just write x to the 6th. And for the y's, I have to add together 2 and 4, so I'd get y to the 6th. And there's my final answer. And now you have reviewed all the exponent rules you need to know to start our next section.